This is problem number 41 from section 5.4. If there was a problem for the Confusion Hall of Fame, it would be this problem. Because it seems so simple. I am going to do this problem twice. I'm going to do it wrong, and then I'm going to do it right.
Why would you do it wrong?
Because I want to acknowledge for the people who watch this video later that they should not feel bad that they got it wrong, because almost everyone gets the wrong answer. Here's the wrong answer. The wrong answer is the integral from 0 to 3 of 2 minus x dx, which is the antiderivative of this is 2x minus 1/2 x squared from 0 to 2, which is 2 times 2 minus 1/2 of 2 squared, which is 4 minus 2, which is equal to 2. But 2 does not equal 5/2, which they say the answer is. Oh, you know what? I'm sorry. I did that wrong. I did that wrong.
Wow.
Let's try that again. I did it wrong, but I did it wrong when doing it wrong. Okay, here we go. It's evaluated from 0 to 3, which is going to be 6 minus 1/2 times 9 minus the quantity 2 times 0 minus 1/2 times 0. That's better. So this ends up being 6 minus 9/2, which is 12/2 minus 9/2, which is 3/2, which is,
How is that wrong?
well,
Yeah, how's that wrong?
well, one, it still doesn't equal 5/2, which they say the answer is. Why is it wrong?
What if they're wrong?
Because they didn't ask this question.
What?
I wouldn't know. This is very subtle, and it comes up on the AP exam a lot. This is not the question they asked. They asked, what is the area between the curve and the x-axis? So let's look at that question again with new eyes. 2 minus x looks like that from 0 to 3. The area is this triangle and this triangle. Now, the integral will give, quote unquote, negative area here. But why do we put the negative area in quotes? Because there's really, yes, Megan. Go ahead.
Sorry, do we have to figure out where then it crosses the x-axis to figure out the two triangles?
Yes, there's two different ways you can do this problem. One of them is to say, you know what? I see that it crosses, and it ends up crossing here at 2. This question is really answered by saying, what is the integral from 0 to 2 of 2x minus x dx? That produces, quote unquote, positive area. Now, the other integral from 2 to 3 produces negative area, so we're going to subtract the negative area that comes from this, from that integral.
So, all triangles are squares.
All right.
Just know from the fact that it says the total area.
When they say total area, that is going to be a thing that you should respond to. It's like, watch out for the negative area thing. Now, I said we could do it this way, and we can, and we get 2x minus x squared evaluated from 0 to 2 minus 2x minus x squared evaluated from, did I forget a half in there? I sure did. Is that better?
Yeah.
All right. And let's see if we now get their answer. And we put in 2, and we get 4 minus 2 squared is 4 divided by 2 is 2, minus the quantity, 3 times 2 is 6, minus 1/2. You know what? I'm sorry. Can I do something I forgot to do? 2 times 2 is 4, minus 1/2, 2 squared is 2. That's evaluating it at the high end. I forgot to evaluate it at 0.
Yeah.
2 times 0 minus 1/2, 0 squared. So that's this part. What about this other part? Minus 2 times 3 is 6 minus 3 squared is 9, minus 9 halves, minus this thing evaluated at 2, which is 4 minus 2. So, cleaning this up, this is 2, that's a big old 0, so minus 6 minus 9 halves is
1.5.
3 halves,
What?
minus
Oh, so it's the same thing.
2.
It's the same thing. I thought you 3.
So we're going to distribute that negative through there, and we get 4 minus 3 halves. We get 8 halves minus 3 halves, which is 5 halves. Now, I said that finding the 0 and doing it as 2 separate integral is one way to do this problem. Megan, do you know there's another way to do this problem?
You're gonna show it, aren't
I
you?
sure am.
Oh, yeah.
Are you ready?
Oh, I know.
So ready.
Go ahead.
Where's my pencil?
The triangles and areas.
What is the area of this triangle?
I think it will be that's 2.
It's 1/2, 2 times 2.
So 2.
What is the area of this triangle?
1/2.
1/2, 1 times 1. So this is
2 plus 1/2.
2 plus 1/2, which is
That's all I did. That's
5 halves.
I literally did.
So which way is acceptable? Answer. Both are.
Well, yeah.
Instead of doing these all
How do you know which one to use?
How do you know which one to use? Well, when the shapes are relatively simple shapes, like triangles or trapezoids, you should feel free to just do them as those kinds of areas.
So as long as it's linear, you can just...
Yeah. Or there's another set of problems where like the curve is like a half circle, and you're expected to use the formula for the area of a circle and multiply that by 1/2 to do those kinds of areas. So you can look for those possible places to do that. Is everyone okay with this problem? All right.